This video is intended for entertainment and historical purposes only. It's not meant to be an instructional tutorial or provide professional advice. Welcome back. Today we're going to carry on right where we left off in the last video. In case you missed it, here's a quick recap. In the last episode, we started restoring the brake and reverser controls for both locomotives. This required a whole new brake lever to be shaped and milled for engine number 1. Using our one existing brake pawl as a template, we fabricated new reverse lever blades and an identical pawl for engine number 2. Today, we're going to continue on and fabricate 6 new triggers, a whole new reverser quadrant, and a host of other parts. By the end of the video, we'll mock everything up on engine number 2 so you can see exactly how it all goes together.
This is fabricated out of 3/4 inch pipe and bits and pieces. So we're going to go through now how I did this. Getting the pieces cut, get them together, figure out how I put it together. Each one of these has to be made for a specific lever because this space here is different in them all. They're just sort of cobbled out. So I'm going to build one by each. All of the parts on this machine are numbered. So this is a number 3 lever. So all of these parts from here to here will all have a number 3 on them so that somebody in the future can put them back where they came from. To make all the levers, of which there are 6, including the throttle, I'm now going to make up all of the components that makes up each one. So this is a spacer. This is my piece that I've cut. I'm going to use it as a template, and I'm going to cut 4 more now. This is the 5th one. I lay them on here. I line it up. And I cut it off using my old high school hacksaw. It works really good. This machine was built in 1948 and was used in all of the high schools around the area. And eventually they went surplus to band type hacksaws. This is a great old girl. It'll gnaw away. You can walk away and it'll cut off up to 6-inch material. Never gives any trouble, doesn't use much power. I kind of prettied it up with a paint job, but that's about it. The hacksaw blades are readily available, and funnily enough, they work just as well forward or backwards, so you can wear both ends. You notice that the blade is worn on the front end where you couldn't possibly cut. That's because already I've turned it around and it's running backwards. When it finishes the cut, it doesn't shut the motor off, but it does kick itself out of gear, which it's about to do. And there you have it. I've got to make up 12 washers as parts of the component of the levers. And so what I'm doing is I've made a couple of them already. This is my template. I've actually machined it off, countersunk it, made it look good. I'm parting it off with a Colchester. I use this as a guide to get the same thickness every time. And it's simply a matter of just parting them off. I need 12 of these. Give it just a little bit of oil, and the parting tool just starts to work. And there you have it. And that's how it's done. I do this 12 times, and I end up with 12 of these. So this is how we make these parts. This is the handle. Started out life as that. Question you may have is, how do I split? This is just standard Schedule 40 pipe. Made up a jig. I've got a piece of steel here that clamps in the vise of the hacksaw. The trick with the hacksaw, especially a reciprocating hacksaw, is it wants to follow the line of least resistance, and I don't want the blade to slide off down here and get cutting in the wrong place. So I've made a pre-cut little notch so it will start, hopefully, where it's supposed to. And I just leave it in the reciprocating hacksaw and it'll gnaw its way across. And I'll end up with a piece on one side like this, piece on the other side like this, and that makes me two clasps. We'll do this again. So this is now mounted in the hacksaw. It's sitting about where I want to have it. And it's simply a matter of engaging the machine and letting it do its thing. So just reach over here and slap it in gear. And it will, for the next while, gnaw away across this piece of material. It's pretty wide. It's like it's a 6-inch cut, so it takes quite a while, and the blade is getting dull. But you can see it is, by the sound of it, and it's gnawing away here. And it'll work its way all the way across and then fall down and go down and fall down and go through the bottom, and I'll end up with 2 pieces. So here we are with the 2 pieces cut off. They got to be cleaned up. This one gets cut off with the zip wheel. Cut it off carefully. I should point out that a lot of people don't know this, but a lot of pipe starts out as a flat strip of steel and goes through a machine and is turned rounded around and then welded together. Through a process called electric resistance welding, and that's the inside of what you see. The outside has been smoothed off. You can barely even know it's there. This is referred to as ERW pipe, as opposed to seamless, where it's actually a solid billet that's drawn through dies to make it a better pipe. This stuff is fine for what it's used for steam. It wouldn't be used for high pressure hydraulic. You might use Schedule 80 and maybe steamless because it's just slightly stronger. There's always little faults can show up in this weld, but this is just a cheap piece of pipe and it's perfectly suitable for this. So here's all the bits and pieces ready to be all welded up into assemblies that'll end up looking like this one. I use these 2 washers as spacers because these levers need to be fairly loose. You don't want them too snug. So this is how the world goes. It's all just laid together. I'll put it in the welding vise, clamp it all down so it can't move, and weld it as an assembly. The purpose of this pin at the top is so I can look down on it and see that it's square and remains square with the shaft. So these are the handles all finished. Manufactured pins, or in the process of manufacturing up pins. 2 of these handles have, or one of these, have 1/2-inch holes because one engine, for some reason, the pins were drilled out to 1/2-inch. And so I'm just maintaining it, the originality. These are the straps that, 1 set out of 4. So I have to manufacture a bunch of these, and these are off the engine that had the 1/2-inch holes. They're 1/4 inch thick, and some engines you'll see quite thin straps. I don't know, this is original, so I'm just going to copy it. So there you have it. We manufactured some nice handles. The reason for the handles having the curve on the end is to fit your hand. The strongest part of our hand is between our thumb and forefinger, and so this is designed to fit your hand because you're grabbing with these fingers. Conversely, on the throttle, this is a throttle, the lever is the other way. You sit in the locomotive on the right side, and this is how you grab the throttle. Again, the strongest part of your hand is here, and you're grabbing it in this curve. That's why these handles are, when they're straight, they're rather awkward. They don't feel right. So this is the reverse lever. As you can see, we made a new pawl for it. It has a spring in it that keeps it doing its thing. Now I have to make a strap that goes between here and here. This sits up like this. So I have welded 2 pieces of 1-inch by 1/4 inch iron together. I've drilled the holes at the appropriate distances, and I'm now going to machine this down to the right profile in the shaper. This needs to go down to 5/8 in the middle, and it's 1 inch across at the end. So this is the setup in the shaper. It's just a matter of reducing the center section. We're going to leave the ends alone Just cut out the middle piece to keep it parallel. I've got a couple of cotter pins through the holes on each side. Makes it easy to make it level. It helps to have a monster vise like this. So it's just a matter of machining it down and turning it over. All the other straps were done the same way. So this is the finished product. This is too long intentionally, as well as this is too long intentionally, because we don't know where it is. The quadrants that are on these engines are bolted to the boiler, not the frame. So it's almost impossible to fit these until all of the other components, the quadrants, everything is in place. And so you can figure out how long these rods need to be so that when this is in this position closed, that the quadrant is probably somewhere up in here. But we don't know what that is until we get it together. So this is put together, all the bits and pieces are here. And when the boiler gets put back on the frame and everything is good to go, then we'll figure out what to do with these things.
The brake and reverse handles both pivot on a single casting bolted to the side of the firebox. You can clearly see this arrangement on engine number 2. Here is where the casting was bolted to engine number 1's boiler. And same with the spare boiler. For whatever reason, the measurements between the pivot point and the quadrant studs are different on all 3 boilers. These different measurements mean that the pawl and strap lengths each need to be specific to the engine they're mounted to. That's why they're made oversized right now and will get fitted up during final assembly.
So we're going to move on to the actual quadrant that goes in here. It has to be machined. We only have one, I have to have 2. So we'll start that process. So we're in the process of bending some iron to make a new Johnson bar quadrant. One is missing. And to that end, we've got a 1" by 2" bar. We've got it clamped in the big vise on the shaper, which doesn't move around. It weighs 6 tons. And we have the other end supported in this vise on the welding bench so it doesn't go up and down. It remains horizontal. And we've done a pretty good job of heating this with the rosebud, section at a time, but we're out a little bit here. We got a little too exuberant, and when you start, you never really know where you're at, and it's difficult to gauge it, so we've overbent it. So what we're going to do is we're going to heat this area up under here and bend it back so that we get a nice profile. The process consisted of starting out with a straight bar, of course, and heating here. The only way to bend iron manually with a big rosebud on a torch is a little bit at a time, and the trick is to know where to heat it and where not to, so it follows what you want it to do. So you generally heat this section, bend a little bit, and you work your way along, heating it more on the outside than the inside because the inside wants to crush. Bending iron this way is referred to as bending the hard way, because of course it's easy to bend it across its width, but across here is a little more difficult, and it's difficult to keep it from doing this on you. So that's why it's supported in the vise. So it follows around, moves around as we bend the iron, keeping it straight and flat. And as you can see, we didn't do too badly. It sits flat. There's no messing around. We just got to fix this one little spot, and we didn't film this because it's awful hard. There was 3 guys involved in doing this as it is. So we're going to just straighten this out, just a tad here, heating it, and we'll set the camera up in the background and you can see us do it. Now we're using an acetylene rosebud, which is a lot of heat, but it's easy to control the heat. Okay, give her. Oop, that's enough. So we'll just let that cool, just the way it is. And then we'll whack it off on two sides and start machining the teeth. So starting work on the quadrants. And it's been a bit of a mystery as to just what's been going on until I discovered that this is the brake quadrant off of number 1. And it had been bent, collapsed downwards. So the holes didn't line up, nothing lined up. So we put it in the big vise on the shaper and we straightened it out again. That's what this heated portion is here. So now it pretty much matches. So now we're working on, I have the brake quadrant for number 1 here, brake quadrant for number 2. They match each other. So now I've got to cut the teeth in this piece to match this. We discovered that there's extra teeth have been cut here and things didn't fit. Well, it turns out that somebody at some time or other got this switched around. They had this marked as the front. You can see the chisel mark there that says F. When in fact it's actually the back. They cut two extra teeth here, another hole here, trying to sort it all out, when really they just had this piece in backwards. So now it's laid out the way it should be. This is the back. The lever sits here, the pawl goes in this hole, and you go all the way to the other end with the original hole here. The lever sits here, the pawl goes in this hole, not these two that were cut out later. This is the actual last original hole. And mid-gear, and that makes 11 teeth. And mid-gear, of course, is in the middle. This is mid-gear. So there's 1, 2, 3, 4, 5 notches each way. 2, 3, 4, 5. These shouldn't be here, nor should this hole. So we're going to machine the other one to copy this side, just like you see it. I'm actually going to tack them together and drill the holes and cut all the teeth. Using these teeth as a guide, just go straight across with the mill, and that should work okay. I just have to cut these teeth out, and then I will finish the profile on the shaper of these. So I'll cut the bottom of the tooth, and then I'll just do the top. So how we're milling the slots out in the reverse quadrant, it's pretty straightforward. We just keep moving this bar along as we do each slot. Center the milling cutter in the bottom of the slot down to here, and very carefully center it in here, and then we cut this out down to a given depth. We do each one. It's not very difficult. I don't know if you can see this. There's some interesting things going on. These were gang done. In other words, there was a stack of them all bolted together and done in a shaper. You can see the torn material in the bottoms where the tool was going back and forth across, and they probably made 4, 5, 6 of these at a time because it saved a lot of setup time. These last 2 teeth don't belong here. They've been handmade, and they're not going to be redone. So it's just a matter of running a 5/16 milling cutter down to a given depth, which I memorize on this wheel here at 0, and just set up and cut, set up and cut, set up and cut. And when we're done, we're going to put it in a shaper and cut the actual profile of the tooth. It's a lot less work once the teeth are cut. You can see these 2 are finished. This one's in the process of being cut. It's just back and forth, back and forth. So here I am in the shaper. All of the teeth that we're going to make have been taken out with a 5/16 mill, but they're square at the back. And we're using this as a template. And so I have already profiled these pieces. This tool has been ground to roughly fit the profile. I use this center one because it's unworn. The rest are quite worn. And it's just a matter of advancing the tool down into the work. It will cut the back and not hit these teeth until I get to the bottom. And that gives me a profile that I need for the reverse quadrant. So I'm just going to take the hand wheel and advance the tool down into the work. And there you have it. This tool was made up a little wider than this gap because these ones are quite badly worn. So you'll notice that we took material off both pieces. But now we have a good square. The forward one, which is the worst, is quite well worn because it jiggles back and forth. The reason for cutting them out with the mill first is it's quite a plow for a square tooth like this to try and go through the material, and it tends to tear more than cut because you can't get any sort of angle on the tool to make a curl come off, so you're just basically bulldozing it out. So if you pre-cut it, it's not too difficult. So this is the finished product. The teeth exactly match the other teeth. Looking down on them, you can see that in some spots we actually hit the other teeth a little wider. Others we didn't. These were kind of varied. They're all the same depth now. One thing that needs to be clearly understood, this is not a gear. So there isn't a mating gear that has to fit these. These teeth are actually not all that well spaced. They're out a few thou here, there, and everywhere. But it doesn't matter because there's only one blade goes down in these at a given time. It only has to index in one hole. And when we put this together, we'll grind the blade to fit down in this and latch securely. So we're making up the reach levers that goes between the brake and the Johnson bar and the valve gear and the brake rod. So this is an original one that we've copied to get the same shape. I've made up the other ends. This is just 1.5 by 1.5 bar that's been bent around a block, forged around a block, and a pad made to weld it on the end. When I know exactly how long they've got to be. This one is for the Johnson bar. The problem I have now, of course, is I don't know what these lengths are going to be because the controls are bolted to the boiler, and of course the valve gear is bolted to the frame and the brakes, so I don't know exactly what that distance is until such time as the boiler's mounted on the frame. So I'll leave it at this point. I'll drill and fit these holes, and but the rest I can't do until the boiler's being assembled. There's only two places to adjust the valve gear on these locomotives. One is the length of this rod, which determines where the Stevenson links are at the top and bottom position, or full ahead and full back, and on the valves themselves. And so you got to be careful what we do here. Steam engines run in 4/4 time, and a human ear is really good at picking up when 4/4 time isn't quite right. And so one of the pride of doing engines like this is that when they're running, the exhaust beats are exactly the same. And so you're aiming towards that.
Although the levers still require final fitting, some paint, and a bit of polishing, you can clearly see how nicely they turned out. I hope you all enjoyed this aspect of the restoration. If you haven't already, hit the like button, leave me a comment, and subscribe so you don't miss out on future videos. And if you're liking the project, here are a couple other episodes from the series.